Good morning, everyone. It's Mrs. Capizzi, and today is Wednesday, April 29th, 2020. And today we'll be working in the Topic 10 review section. So today's assignment is page 580, the vocabulary review, and, page 582, Reteaching Sets D and E. Now, if you want to know where we are on the list that was sent home, today's video will be about day 8, so we'll be working in this section today. So let's go ahead and get started. All right, so let's go over this vocabulary review. I had already put an answer for number 1, so I just wanted to cover that up. So for numbers 1 through 5, you need to put a T if it's true and an F if it's false. So if you think the statement is true, you'll put a T, and if you think the statement is false, you'll put an F. So I want you to pause the video, try numbers 1 through 5, and then when you have your answers, I want you to press play and check your work. So here I am just going to go ahead and highlight for you or underline the vocabulary words. So benchmark fraction is your vocabulary word there. Equivalent fractions are your vocabulary word there. Denominator is your vocabulary word for number 3. And fraction is your vocabulary word for number 4, and numerator is your vocabulary word for number 5. So pause the video, and when you've done number 1 through 5, go ahead and press play. Okay, we are back. Let's go ahead and check our work. So number 1, I've already have done here. So a benchmark fractions are commonly used fractions such as 1/4 and 1/2. That is true. So I put a T there. Number 2, equivalent fractions are fractions where the numerator and denominator have the same value. That is false, because if the numerator, let's say, is 3, and the denominator has the same value, which is also 3, that's not an equivalent fraction. That's a fraction that's equal to 1 whole. So number 3, the denominator of fraction tells the number of equal parts in the whole. So remember, numerators on top and denominator, D for down, is on the bottom. So our trick was N is for north, which is up, and D is for down. So the denominator tells the number of equal parts in the whole. That is true. So for example, if I had 3/7, that means that there are 7 equal parts. So that tells me how many equal parts. The denominator tells you how many equal parts. So 3/7 would be I have 3 equal parts out of 7 total parts. Number 4, a fraction names part of a whole, part of a set, or a location on a number line. That is true. So here, for example, we'll just use 3/7 again. So the whole would be 7. So 3/7 would be part of the whole. I could also have a set of something. For example, if I had 7 paper clips and 3 of them were blue, so I have a set of paper clips and 3 out of 7 are blue. So that is what they mean by a set. So a set is just a set of something. And then here, the numerator is the number below the fraction bar in a fraction. That is false. The numerator is the number above the fraction bar. So that one is false. So now what I want you to go ahead and do is pause the video again, and for 6, 7, and 8, you're writing if this statement is always true, sometimes true, or never true. And then for number 9, it says use vocabulary in writing. So we're going to be writing 3 statements. So it says Samantha wrote 1/2. Use at least 3 terms from the word list to describe Samantha's fraction. So your word list is up here, so you want to make sure that you're using 3 of these words in a sentence, not just listing the words out. So go ahead and freeze the video, and when you're ready to come back, once you've done 6 through 9, press play and we'll go over the answers. Okay, so welcome back, and here our vocabulary word is unit fraction. So it says a unit fraction has a numerator of 1. Is that always true, sometimes true, or never true? A unit fraction always has to have a numerator of 1. So that would be always true. So number 2, a numerator is greater than its denominator. So is that always true, sometimes true, or never true? So a numerator could be greater than its denominator, such as 7/3, but that's not always true. Sometimes the numerator is less than the denominator. So this would be sometimes. Number 8, a mixed number has just a fraction part. That is never true, because we know a mixed number is a whole number and a fraction. They're mixed together. So an example of that would be 2 and 1/4. 2 is the whole number, 1/4 is the fraction part, but together they make up a mixed number. So a mixed number can't just have a fraction part, it has to have a whole number and a fraction. So here, Samantha wrote 1/2. Use at least 3 terms from the word list to describe Samantha's fraction. So we know from number 1 up here that 1/2 is a benchmark fraction because it's a commonly used fraction. So that's something you could have written. 1/2 is a benchmark fraction. You could have also said the numerator of 1/2 is 1, because the numerator is the number on top. And you could have also said the denominator of 1/2 is 2. There's also, you could have said 1/2 is a fraction. And also think about, is 1/2 a mixed number? It's not, because it does not have a whole number. So 1/2 is not a mixed number. And also the numerator here is 1. So I could have also said 1/2 is a unit fraction, and I know that because the numerator is 1. So that is the vocabulary review page, so hopefully you guys did okay with that. Now what I want you to do is we're going to be working on the next page. Sets sets D and E. So first we'll take a look at set D. Let me just focus in here better. So if I look at my example here, they're using multiplication to solve 5 times 3 and 1/3. So here they showed you the picture of how they use the distributive property. I am going to write this out so that it looks a little bit more familiar. 5 times 3 and 1/3. When we were doing this earlier in the topic, we broke this apart into 5 times 3 plus 5 times 1/3. So here 5 times 3 is 15, and 5 times 1/3 is 5/3. So here they showed you that 5/3 is equivalent to 1 2/3. So just to prove that, 5/3, I'm going to see how many 1 wholes I can make. So 3/3 would be 1 whole, and then 3 plus 2 is 5, so that would be 2/3 left over. So if I circle my 1 whole, this would be 1 whole, and then I smush the fraction right next to it. So that's how they got the 1 2/3. So 15 plus 5/3 is the same thing as 15 plus 1 1/3, which equals 16. I'm sorry, it's the same as 1 2/3. My fault. So that would be the same. 15 plus 1 is 16, and 2/3 I just put next to it. So let's take a look at the examples here. Now again, they do not give us a lot of room, so feel free to do this on a separate piece of paper. I'm just going to do these on a sticky note under here so that I have some more room. So number 1, set D. It takes 2 1/4 yards of ribbon to make a bow for a gift. Serena made 7 bows. How much ribbon did she use? So here, this is a multiplication problem. She's making 7 bows times 2 1/4 yards for each bow. So I'll use the distributive property and break this apart. I'll have 7 first times 2 plus 7 times 1/4. 7 times 2 is 14, plus 7 times 1/4 is 7/4. And I look here and I do need to rename 7/4 because the numerator is larger than the denominator. So 7/4, I'll see how many 1 wholes I can make. So my denominator is 4, so 1 whole would be 4/4, and 3/4 left over. So if I circle, this makes 1, and I just smush the fraction right next to it. So 7/4, I'm going to rename that as 1 3/4. So here I will have 14 plus 1 3/4 equals 15 3/4. So to answer how much ribbon did she use, she used 15 3/4 yards of ribbon. Okay, so that's number 1. And I'm going to put this off to the side. Let's take a look at number 2. There were 5 students that walked 3 3/8 miles as a group during a walkathon. How many miles did the 5 students walk all together? So go ahead and pause the video, and I want you to try to solve this. So it's 5 students and they each walked 3 3/8. So you're going to multiply. So go ahead and pause the video, and then when you're ready, press play and we'll go over the work. Okay, mathematicians, let's go ahead and finish up number 2. I'm going to use my distributive property, break this apart into 5 times 3 plus 5 times 3 ace. 5 times 3 is 15, and 5 times 3 eighths. 5 times 3 is 15, 15 eighths. And I do need to rename this because my numerator is more than my denominator. So 15 eighths, I'm going to make 1 whole, which is equal to 8 eighths, and I cannot make another 1 whole because another 8 eighths would be 16 eighths, and that's too much. So there would just be 7 eighths left over. I'm going to circle all the fractions that equal 1 whole. So this would be 1 whole and 7 eighths. So I'm going to rename this 15 eighths as 1 and 7 eighths. So 15 plus 1 and 7 eighths equals 15 plus 1 is 16 and 7 eighths. So let's write a sentence. How many miles did the 5 students walk all together? The 5 students walked 16 and 7/8 miles all together. So easy peasy. You just have to remember to rename all the fractions where the numerator is more than the denominator, but we've had lots of practice with that, so hopefully you guys feel pretty good. All right, the last section here, set E. So again, these were the problems that we've been working on in 10-5, and you will need the units of time here. Let's just review real quick. 1 hour is 60 minutes, 1 year is 12 months, 1 day equals 24 hours, and 1 week is 7 days. So you do need to check to see if you have to regroup or rename. So let's take a look at number 1. It's 7 hours and 12 minutes plus 3 hours and 53 minutes. So adding is easy enough. First we'll go ahead and add our minutes together. 2 plus 3 is 5, 1 plus 5 is 6, and then we'll add our hours together. 7 plus 3 is 10. So I'm left with 10 hours and 65 minutes. But this 65 minutes is more than an hour. It's more than 60 minutes, so I need to rename this. So I'm going to take away 60 minutes and rename that as 1 hour. So 65 minus 60, so I'm left with 5 minutes. And this 1 hour, I'm going to move to the hours. So 10 plus 1 is 11 hours. So number 1, the answer would be 11 hours and 5 minutes. So you might have another strategy of how to do this, but when I'm renaming, I just like to take away what I'm renaming, so I know I can take away 60 minutes and replace it with 1 hour. And then I move the 1 hour over to the hours column. So that's number 1. Now let's go ahead and look at number 2. So again, pause the video, give it a try, and then press play. Alright, so, oops, I have 2 stickies here. Number 2, 7 times 3/4 hour. So to solve a whole number times a fraction, I just take the whole number times the numerator. 7 times 3 is 21, and my denominator is 4. So I do need to rename this. So I've got 4/4. I'm going to see how many 1-wholes I can make, plus 4/4. 4 plus 4 is 8, so I need to keep going, plus 4/4, that's 12/4, so I keep going, plus another 4/4, that's 16/4, so I keep going, and I can do another 4/4. So 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20, and that's as close as I can get, and that would leave me with 1/4 left over. So if I circle all my 1-wholes, I've got 1, 2, 3, 4, 5. So this would equal 5 and 1/4. And you may have also done that if I do my skip counting by my denominator. So if I have 4, 8, 12, 16, 20, that's as close as I can get, and I can see that that's 1, 2, 3, 4, 5. So that's where I get my whole number and the 1/4 left over. Okay, let's take a look at number 3. So go ahead and pause it, and then we'll go over it once you have your answer. But remember, you cannot take 6 days away from 4 days, so you will need to regroup. Okay, so let's go over this problem. I'm going to show you what not to do. So many students will do 6 minus 4 and say this is 2 days, and 5 minus 3 is 2 weeks. No, 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 no. Okay? You cannot take 6 days from 4 days. So in that case, you needed to regroup. So let's go over how to do that. So for number 3, I've got 5 weeks and 4 days, and I'm subtracting out 3 weeks and 6 days. So I'm going to I need to use this unit of time. I know that 1 week is 7 days. So I can't take 6 days from 4 days, so I'm going to go over to my weeks, take a week away, so I'm left with 4 weeks, and I need to add that back in as 7 days. So 4 plus 7, my new top number will be 11. So now I've got, oh, sorry about that, 11 days minus 6 days would be 5 days, and 4 minus 3 would be 1 week. Okay, so the last one for today, number 4, write 560 days in weeks. So I know that 7 days equal 1 week, and they gave me the number of days. So 560 days equals how many weeks? So since there's more days than there are weeks. If you look at the quantity, I am going to have to divide. So I would take 560 and divide that by 7. So 5 divided by 7, I can't do that, so I'll put an X above there. And I know that 7 times 8 is 56. So 56 divided by 7 is 8. 8 times 7 is 56. And 56 minus 56 is 0. And don't forget to bring down this 0. And then 0 divided by 7 is 0. So once you have zeros down here and a 0 up here, you're done. So 560 days equals 80 weeks. And if you wanted to check your work, remember the inverse operation of division is multiplication. So I could take 80 times 7. 7 times 0 is 0. 7 times 8 is 56. And I can see I can check my work and get back to the 560 days. Please reach out if you have any additional questions. Reach out to your teachers, or you can contact me directly. If you're not one of my students, I'd be happy to help. I hope that you guys have a wonderful day, and we miss you all very much, and I will talk to you tomorrow. Have a wonderful, wonderful day.